Hello Sec 4 and 5, this will be your final revision lesson for your chemistry practical. In this lesson, we are going to cover a few areas. We are going to recap on a few tests, mainly for the cations, gases, anions, reducing and oxidizing agents. We are also going to look at a few possible results for heating of unknown substances and some writing style to prepare yourself for the practical exams. Let's start with the test for the cations with sodium hydroxide. Add a few drops of sodium hydroxide to an unknown solution. You may or may not observe a precipitate. If there's no precipitate formed upon adding a few drops of sodium hydroxide, when you heat the solution and if there's no gas being evolved, this unknown solution would have contained the sodium or the potassium ions. But if there's gas evolved, this unknown solution contains the ammonium ions. If you observe a precipitate being formed after adding a few drops of sodium hydroxide, you need to take note of the color of the precipitate. If a white precipitate is formed upon adding excess sodium hydroxide, if that PPT is soluble in excess, this unknown solution would have contained either the zinc or the lead 2+ ions. But if the PPT is insoluble in excess, this unknown solution contains the calcium 2+ ions. If you observe a blue precipitate upon adding a few drops of sodium hydroxide, and in excess sodium hydroxide, the blue precipitate is insoluble in excess, this unknown solution would have contained the copper 2+ ions. And if you observe a dirty green precipitate upon adding the excess sodium hydroxide, and if this dirty green precipitate is insoluble in excess, this unknown solution would have contained the iron 2+ ions. And iron 2+ ions would actually oxidize in air if you let the test tube stand on a test tube rack for a few minutes. Okay, and what would you observe is that the dirty green precipitate would actually turn to a reddish brown precipitate. And if you add a few drops of sodium hydroxide into the unknown solution, and if you observe the reddish brown PPT in excess, if the reddish brown PPT remains insoluble, this unknown solution would have contained iron 3+ ions. Now we'll move on to the test for the cations with aqueous ammonia. The test between the sodium hydroxide and the aqueous ammonia is very similar. The only difference would be over here. Okay, when a white precipitate is formed in excess aqueous ammonia, if the PPT is soluble in excess, this unknown solution would have contained the zinc 2+ ions. And in PPT insoluble in excess, this unknown solution could be either containing the calcium 2+ or the lead 2+ ions. So now let's do a few checkpoint check before we move on to the next section. Okay, when a solution X is mixed with a few drops of sodium hydroxide, a white precipitate is formed. So what is the cation that would be present in this solution? So if you refer back to the flow chart, okay, if it's a few drops of sodium hydroxide and a white precipitate is formed, most likely the solution would contain the zinc 2+, lead 2+, or calcium 2+ ions. However, to differentiate between the three, okay, you must add into excess sodium hydroxide. Because in excess sodium hydroxide, if the solution contains calcium 2+, the PPT will be insoluble in excess. Let's move on to question 2. When solution Y is mixed with a few drops of aqueous ammonia, a green precipitate is formed. Okay, so a very strong hint is that green precipitate is formed. So what is the cation that is present? It will be iron 2+. And please note, if iron 2+ is oxidized by air, the precipitate will turn from green to brown. And now we'll move on to the test for gases, and there are 6 different types of gases that you will need to know for your science practical. 6 different gases are hydrogen gas, oxygen gas, carbon dioxide gas, ammonia gas, chlorine gas, and sulfur dioxide gas. To test for hydrogen gas, you will use a lighted splint. And what will you observe is hydrogen gas is present is that the lighted splint will extinguish with a pop sound. For oxygen gas, you will use a glowing splint. So often, many students will mix up between the lighted splint and the glowing splint. Okay, the glowing splint will rekindle if oxygen gas is present. For carbon dioxide gas, if you bubble the gas through lime water, and if carbon dioxide gas is present, a white precipitate will be formed in the lime water. If ammonia gas is present, you will have to test it with a moist red litmus paper, and if the moist red litmus paper turned blue, ammonia gas was present. For chlorine gas, you will use a moist blue litmus paper, and if chlorine gas is present, the blue litmus paper will turn red and then it will bleach into white. And for sulfur dioxide gas, you will use acidified potassium manganate, and the purple solution will actually turn colorless. Let's move on to the test for anions, and there are 4 different types of anions that you will need to know. You will need to know the test for carbonate ions, sulfate ions, chloride ions, as well as nitrate ions. To test for carbonate ions, you will need to add acid to the substance. And if there's effervescence occur, and if you bubble the gas through lime water, a white precipitate is formed. This is because carbon dioxide gas was produced, and with that, we can conclude that carbonate ions are present. To test for sulfate ions, we will add in acidified barium nitrate. And what will you observe? You will observe a white precipitate form. And the white precipitate is actually your barium sulfate. To test for chloride ion, you will add in acidified silver nitrate solution. Upon adding this solution, a white precipitate is formed if chloride ions are present. And this white precipitate will be silver chloride. And for your nitrate ion, if you add sodium hydroxide together with aluminium powder or foil, and if you warm it gently, if nitrate ion is present, you will observe an effervescence, and if you test for this gas, the gas will turn moist red litmus paper blue. This is because ammonia gas was produced, and with that, we can conclude that nitrate ions are present. Some question before we move on to the next section. What am I testing if I add sodium hydroxide and aluminium foil and powder and warm the mixture gently? Okay, if you do a bit of recap, you will realize that sodium hydroxide is also used to test for cations. And if I add aluminium foil or powder and I warm the mixture gently, I'm also testing for nitrate ions. So for this, both the cations as well as the nitrate ions are being tested. So based on the observation, you will be able to conclude which cation is present or whether nitrate ions are present. Okay, when the acid is added to a substance X, effervescence is observed. Okay, so what could the substance be? Okay, so substance X, okay, when they are added acid, there will be effervescence. So if you think carefully, what are the different reactions of acids? that will produce effervescence. Okay, when acid reacts with carbonate, okay, you realize that there will be an effervescence being observed. Okay, so substance X could be a carbonate. Another reaction, if you use a reactive metal and you react with acid, okay, hydrogen gas is also observed. Okay, so substance X could be a carbonate or a metal. Okay, now let's move on to the test for reducing and oxidizing agents. Okay, we're going to take and recap a bit of the redox reactions. Okay, these are some common reducing and oxidizing agents. Okay, a common reducing agent will be potassium iodide, and a common example of an oxidizing agent will be your potassium manganate. Okay, potassium iodide is used to test for oxidizing agent. Okay, if before adding potassium iodide, if the solution is colorless, after mixing with an oxidizing agent, okay, a brown solution will be formed. Okay, potassium manganate is to test for presence of reducing agent. Okay, the original color of potassium manganate would be purple color. Okay, so after mixing with reducing agent, okay, you will observe the color changes from purple to colorless if the potassium manganate is acidified. If it's a non-acidified potassium manganate, the color changes from purple to brown. Let's move on with heating of solids. If you have an unknown solid and you are required to heat strongly or gently, okay, you will observe a few of the following observations. If the solid sublimes, okay, so from solid it turns to gas, and the gas subsequently cools to form white solid at the sides of the test tube, this unknown solid is an ammonium chloride. If you heat this unknown solid and a white solid is yellow when hot, and when you cool down it turns back to white, okay, this solid would have contained zinc 2+ ions. If you heat this unknown solid and initially it was green in color and it turns black after heating and carbon dioxide gas is produced, this unknown solid contains copper 2+ ions. And if you heat an unknown solid and a pungent brown gas is produced and oxygen gas is also produced at the same time, a nitrate ion is present in the solid. And if you heat the solid, okay, and carbon dioxide gas is produced, carbonate ions is present in this solid. Let's look at some writing styles as well as some common mistakes that are made by students during their practical. Let's start with heating of solids. What's wrong with the answer on the left? Solid is white. Okay, a suggested style of writing would be upon heating, okay, the solid remain white. Okay, the second statement, upon heating, the solid turn yellow. Okay, a better style of writing would be the original color of the solid is actually white. Okay, so you can also state it down in your answer. Upon heating, the solid turned from white to yellow, and upon cooling, the solid turned back to white. Alright, the third one, okay, upon heating, the solid dissolve. Okay, but this answer is lacking a few more points. Okay, so a suggested style of writing would be upon heating, the white solid dissolve in the condensed water vapor to form a colorless solution, or if there's no water vapor being produced, upon heating, the white solid, okay, melts to form a colorless liquid. Okay, the next one, a gas is produced. Okay, but there's no observation about this gas. Okay, a change color of litmus paper. Okay, did not state the color change. Okay, so a suggested style of writing would be a brown and pungent gas evolve. Okay, the gas turned the moist blue litmus paper to red. So you give the color of the litmus paper as well as the color of the gas. Now let's take a look at the writing style, okay, for heating of solution. Upon heating, the solution is green. Okay, like the above, the suggested style of writing would be upon heating, the initial color of the solution is blue. So you can write it down, upon heating, the solution turned from blue to green. Okay, the next point, upon heating, bubbling occurs. We are assuming that the bubbling is due to a reaction instead of the boiling bubbling. Okay, so a suggested style of writing would be, upon heating, bubbling occurs, a colorless and pungent gas evolve. Okay, and this gas, you have to do a gas test. Okay, and the gas turned moist red litmus paper blue. Okay, because if you know that the gas is pungent, most likely it's going to be an ammonia gas, and to ensure that ammonia gas is present, okay, you will actually have to use a moist red litmus paper. So now let's take a look at a few writing styles for heating. Okay, the first one, upon heating, the mixture change. Okay, but there's insufficient details. Okay, so a suggested style of writing will be, upon heating, the precipitate, okay, in the mixture change from green to brown. Okay, if there's presence of the precipitate. Now let's look at some writing style when we add a solution to another solution. Okay, the first point, a precipitate was formed. Okay, so clearly the student did not write the color of the precipitate. Okay, and it dissolves upon adding more sodium hydroxide. Okay, but did not say to form a Okay, next let's move on to the writing style when we add a solution to another solution. Okay, if the student write a precipitate was formed, okay, but what's lacking, it will be the color of the precipitate, and it dissolves upon adding more sodium hydroxide. Okay, so this student write it dissolved, okay, referring to what? Okay, as well as it dissolves to form what? Okay, so a suggested style of writing will be, a white precipitate was formed. Okay, so you state the color. Okay, and the precipitate dissolved in excess sodium hydroxide to form a colorless solution. Okay, so that would be a suggested style of writing. Okay, let's move on to the next one. If the students write effervescent observe, okay, and they state that carbon dioxide gas was produced. Okay, why this statement is not a good statement is because this is actually a conclusion. Okay, because you already state the name of the gas. So this is not an observation. So rather, a suggested style of writing will be effervescence observed. Okay, and a colorless and odorless gas was evolved. Okay, so instead of saying that it is carbon dioxide gas, you state the color, so it's colorless and odorless. Okay, so you have to do a gas test to test the presence of carbon dioxide. Okay, so to test for carbon dioxide, you will use lime water. So you have to state that as an observation. When gas was bubbled into lime water, a white precipitate was formed. Okay, let's move on to the writing style when we add solution or water to solid. Okay, so the first one, okay, effervescence observed, hydrogen gas was produced. So this is very similar to the previous example. Okay, hydrogen gas is actually a conclusion. Okay, so a suggested style of writing would be, okay, effervescence was observed, okay, and a colorless and odorless gas was evolved, okay, and you will need to do a gas test on the gas evolved. Okay, so if you do want to test for the presence of hydrogen gas, you would use a lighted spleen. Okay, so you write that as an observation, gas extinguished a lighted spleen with a pop sound. Okay, the next example, the solid dissolve. Okay, so the same issue, you didn't state the initial color of the solid and you did not state it dissolves into what. Okay, so a suggested style of writing would be the reddish brown solid, okay, the initial color, dissolved to form a yellow solution. Okay, the next example, nothing happened when hydrochloric acid was added. Okay, you cannot write nothing happened. Okay, so if you did not observe anything, okay, if there's no visible reaction, what we will state will be no visible reaction or no observable change. Okay, or if you have observed something, okay, you can continue to write down. Okay, for the next example, if the student write nothing happened when hydrochloric acid was added. Okay, if you do not see any observation, okay, you cannot write out nothing happened. Okay, so what's acceptable would be either no visible change, okay, or no observable change. Okay, so you cannot write down nothing happened. Okay, or okay, if the solid remains unchanged, okay, you may write down something like the brown solid was insoluble in hydrochloric acid. Okay, now let's move on to the writing style when we add solution or water to the mixture. Okay, if the student write out the precipitate dissolved, okay, so it's the same common mistake that you did not give the color of the precipitate, okay, and you did not write in dissolve into or to form a solution and the color of the solution. So a suggested style of writing would be the blue precipitate dissolved to form a deep blue solution. Okay, so the color of the precipitate was given and we also write down what did the precipitate dissolve into. Okay, the next example, the solution became yellow. Okay, so you did not write out the initial color of the solution. Okay, so a suggested style of writing would be the solution turned from pale green to yellow. Okay, so that's the end of the whole revision lecture. Okay, if you have any more questions regarding your practical, okay, please approach your chemistry teacher.